Hello children, welcome to Physics JEE NEET Foundation class. In today's video, from Electricity chapter, some basics we are going to learn. Okay children, let's start the video. So, in this topic, electricity topic, first we are going to discuss about Ohm's law. What is the law name children? It is Ohm's law. Ohm's law. Here, this Ohm's law, it mainly gives relation between two physical quantities, that especially two electric quantities. It gives the relation between two electric quantities. If you observe the picture here, you can see a battery, which is a source of supply, source of electrical supply, and a bulb, which is a conductor of electricity. You are having one source of electricity and one conductor of electricity. You know that the battery will be having two terminals, positive terminal at one end, negative terminal at another end. It will supply some voltage to the conductor. It supplies some voltage to the conductor. Based on the voltage or based on the potential difference, the current will flow in the circuit. Like this, the current will flow in the circuit and the bulb will glow. Means here we are having two quantities. One is V, another one is I. Because of this battery, because of this potential difference, some voltage V is supplied along the circuit, which is called potential difference V, and another one, the current passing in the conductor, which is called I, and because of which the bulb will glow. Means in this diagram, we are coming across two quantities. One is V, another one is I. V stands for potential difference and I stands for electrical current. So this Ohm's law, it gives a relation between these two quantities, these two electrical quantities. So Ohm's law is nothing but it is a law in physics which gives relation between this I and V. Suppose you have what we have observed here, we have attached one battery here and the bulb is glowing with this amount of intensity. Now, if we attach two batteries, then what will happen? The amount of voltage supplied across the conductor increases because this single bulb will provide some voltage. In addition to that, we are adding one more battery, means we are increasing the potential difference. We are increasing the value of V. We are increasing the value of V across the conductor. So then what happens to the light? You can observe. Now it is glowing with more intensity compared to the first condition. Why? Because more amount of voltage we have supplied, and because of that it is glowing with more light intensity. Means more current is supplied to the bulb. That's why it is glowing with more intensity. Suppose if we replace these two batteries with three batteries, then what happens? We have increased still some more amount of voltage or supplying some more amount of voltage. So the potential difference will be more and the current passing through the conductor will be more, and the light intensity this time will be still more than compared to the second condition. Okay children, with these three examples, with these three animated conductors, what we have observed, the current and potential difference, these two are related to each other. The current I and the potential difference V are related to each other. In what way? They are directly proportional to each other. Means current flowing through the metallic conductor is directly proportional to the potential difference V across its end, provided its temperature remains the same. So this current is directly proportional to the potential difference. If potential difference increases, automatically current also will increase. They are directly proportional. But one thing we have to keep in mind, the other physical quantities like temperature, pressure, humidity in the surroundings should be constant. So in that condition, this I and V are directly proportional to each other. So this is about Ohm's law, children. It states this condition. So here the length, area of cross section, temperature, material, not only this, pressure, humidity, if all these things are constant, then V is proportional to I. So length, which is we can take it as L, area of cross section capital A, temperature, the material, because this metallic conductor, this connecting wire, sometimes it may be made up of copper or sometimes we may use another material. So this relation also depends upon what kind of material we are using. If the material also constant, because in first condition we have applied one battery, second condition 2 batteries, third condition 3 batteries we have attached here. But in the 3 conditions, if the material, the connecting wire material is same, then in that condition this V is directly proportional to I. V is directly proportional to I. Or we can also write V by I. If this I comes left hand side, it will become V by I. This V by I remains constant. This ratio value remains constant. And that constant name is resistance. It is denoted by R. So through Ohm's law, finally we can conclude with this formula, children. V by I equal to R. This is the law. This is the formula given by Ohm's law. So R we can also write in another way. V equal to IR. V equal to IR. V equal to IR. So this is known as Ohm's law. Okay, children. So through this law, what we have learned, this I and V are directly proportional to each other, but the condition is all these things to be constant. Okay, next let's see about resistance. Okay, children, resistance. Suppose you have given a conductor, so it will be having some particles inside it. So in the beginning, if they are not attached to any other electrical source, what is the particles behavior? They may be moving in random directions. Suppose if the same conductor, if you attach it in a circuit, if you attach it to a source of electricity, or in a circuit, if you connect it with a circuit, so then what happens? The particles align themselves in different direction. And as we have connected it to a battery, source of electricity, the current starts flowing through the conductor. Suppose when it is flowing through the conductor, because it has to pass from one end of the conductor to other end, because this circle has to continuously rotate, then only we can observe the power supply and the lightning or something. So this flow of electricity should be continuous, means they have to go from one end of the conductor and they have to come out of from the other end of the conductor. While going like that, there inside the conductor we are having so many particles. So that particles, they will try to stop the electrons entering into the conductor, means they will start opposing the flow of electrons, or they will show some resistance to the flow of electrons. So here because of the conductor or because of the particles of the conductor, we are experiencing some resistance. To what? Resistance to the flow of electrons or flow of current. So that's why sometimes what happens while charging the cell phone, we observe that after some time the cell phone gets heated, the battery of the cell phone. Why? Means there to pass through the conductor, it has to do some work. It has to overcome the resistance. In that, some heat energy is burned. So that's why our phone will become hot. So here these electrons, they will experience some resistance because of the particles of the conductor. So when the atoms are more or when the particles are more inside the conductor, the resistance will be more. Because of more resistance, because of more opposition, the current will be less. The current will be less. Suppose in another case, when the atoms are less, so inside the conductor, if the atoms are less, so then resistance will be less. At that time, current will be more. At that time, current will be more. Current will be more. So through this example, what we have learned? So the property of conductor due to which it opposes flow of electrons, that is called resistance, that we have learned. And one more thing, this resistance depends on the number of particles. If particles are more, more resistance. Particles are less, less resistance we can experience. So the SI unit of resistance is ohm, denoted by the symbol sigma, children. It is represented by ohm. So already from the Ohm's law we have learned V equal to IR. V equal to IR. From the same formula, if I want to frame a formula for R means, how can I write? R equal to V by I. Like that we can write. So resistance is equal to voltage by current or potential difference by current. So the unit of resistance is ohm. So ohm equal to volt by ampere. This is the formula for resistance. So if the potential difference is 1 volt and the current passing through the circuit is 1 ampere, then we can say that there is a resistance of 1 ohm. There is a resistance of 1 ohm. Next, children. So this resistance is affected by some factors. So one is length of the conductor. Second, area of cross section of the conductor. Next, material by which the conductor is made. And finally, the temperature in the surroundings. This resistance R mainly depends upon these 4 factors. So length. So how it is proportional to length means, if the length is more, resistance will be more. If the length of the conductor is more, resistance will be more. Means it is directly, one minute, children. So it is directly proportional to the length. So resistance is directly proportional to the length. Suppose, see this picture. In this picture, what you can observe here, if the door is wider, so here if there is an example of metro train. If the door is wider, more people can enter. Means if the area of cross section is more, then more people can enter. And if more people enter, the resistance will be less. Means here if you compare the number of persons with current flow, if the door is wider, more people can enter. Means if the area of cross section is more, then more current can enter into the conductor. That means indirectly resistance will be less. So hence R is proportional to 1 by A. So resistance is inversely proportional to the area of cross section. That is the second factor affecting resistance. If you combine these two formulas, what you will get? R is proportional to L by A. Or if the proportionality, if you change it into equality, then one constant we will get. Here the constant is denoted by the symbol rho. Which is called resistivity, and it depends on the material by which the conductor is made. So the formula for resistance is R equal to rho L by A, where rho stands for resistivity, L stands for length of the conductor, A stands for area of cross section of the conductor. So here children, if you want to check the units of resistivity, rho means with the help of this formula, if we keep it alone and remaining all the terms if we bring this side, then rho equal to R A by L. R A by L, this formula we get, and from this the units will become where, one minute, rho equal to what is the formula? R A by L. R A by L. So where R A by L, where the unit of resistance is ohm and the unit of area is meter square and the unit of length is meter. 1 meter gets cancelled. So what will remain? Rho equal to ohm meter. Rho equal to ohm meter will remain. So the unit of resistivity rho is ohm meter. Ohm meter. So let's try to understand about resistivity in practical way, children. So see this electric circuit. You can see one ammeter which can measure amount of electricity passing through the conductor, and here you are having a source of electricity like battery, and here you are having a switch, and here there is gap between the ends A and B. Now we are by this diagram or activity we are going to understand about resistivity, because if this gap is filled with what kind of material, so then how much resistance will be generated, that we are going to check. Suppose if these AB are connected by copper wire, then the total circuit will become complete and the current will flow. In ammeter we can see the reading of electricity or electric current, which is 30 ampere now. If this gap is filled with copper wire, the current flow is 30 ampere. Suppose in the place of copper wire, if I keep a aluminum wire, then the ammeter is showing 20 amperes current. Means current became less. Why? The kind of material we are using for making connecting wire is different. In the case of copper wire, the resistance is less. So that's why more current it has showed. But in aluminum wire, it is showing more resistance. So that's why it is showing less current. Suppose if it is replaced by glass rod. Now see the ammeter, children, the current reading it is showing 0. Means it acts like a insulator. It is not a conductor. This glass rod offers more resistance, or in turn we can call it as an insulator, not conductor, which don't allow the current. It is called insulator. So that's why no current is shown in the ammeter. Or if you replace the glass rod with rubber, this time also the current is 0. So with this activity, practically we can understand how the resistance depends upon the material. In the case of copper it is different, in the case of aluminum it is different. If we use the glass rod it is 0, in the case of rubber material also it is 0. So that's why resistance also depends on material, the kind of material with which the conductor is made. So resistivity, it is a specific property of a material. One minute. So different materials have different resistivity. So that's why amount of flow of current is changing in all cases. Okay, children. Now we have seen the concept of Ohm's law, resistance and resistivity. So let's see some questions, children, so that we can understand how much concept we have learnt. Here, what is the first question? On what factors the resistance of a conductor depends? So what are the factors, children? It depends on length, area of cross section, material, temperature, and sometimes pressure and humidity also. On that things also it will depend. The main four things are length, area, material, and temperature. Next, second question. How does the resistance of a wire change when its length is tripled, the diameter is tripled, if the material changed to 1, whose resistivity 3 times? Now the question is how the resistance of wire changes based on length, diameter, and resistance if 3 of them are multiple 3 times or triple. So from the formula, children, what we have learned, R equal to rho L by A. Rho L by A, which means R is directly proportional to L. R is directly proportional to L. Means if a length increase 3 times, because it is directly proportional, resistance also will increase 3 times. So directly based upon the formula, we can tell that if length is triple, resistance also will get triple. Next. So R is proportional to 1 by A. 1 by A. So 1 by A. If we take only area, R is inversely proportional to area of cross section. But area means metallic conductor means circle we have to consider. The formula for area of circle is pi r square. In the place of R, we can take a diameter, or radius is nothing but half of the diameter. In the place of R, we can keep d by 2, or r square means it will become d square by 4. D square by 4. So here pi is a constant, 4 is a constant. So this relation we can also write in the form of R is proportional to 1 by d square. R is proportional to 1 by d square. Means if the diameter is triple, 3 square means 9. 3 square means 9 will come here. So what happens? The resistance will become 1 by 9 times. If the diameter is tripled, so R proportional to 1 by d square we are having. R proportional to 1 by 3 d square, because diameter tripled, 3d square. What we will get? 1 by 9 d square we will get. Means 1 by 9 into 1 by d square. To its previous value, it became 1 by 9 times. So the resistance will become 1 by 9 times. Resistance will become 1 by 9 times. Next, children. So we have another relation. So R is proportional to rho. So resistance is directly proportional to resistivity. If resistivity is triple, resistance also got triple. So like this, we can understand the relation, children. Third question. What is the question, children? Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Here they are asking about current flow through a thick wire and through a thin wire. But both of them, they are made with the same material and connected to the same source. Then we have to understand what will happen. So when connected to same source, this current will flow more easily through a thick wire. More easily through a thick wire than a thin wire. Because thick wire means more area of cross section. Already we have learnt resistance is inversely proportional to area of cross section. Because of more area, less resistance will be there and current easily will flow through the conductor. Okay, children. So about these things we have learnt in the video. Thank you, children. Have a good day.